Here we are coming back. And this is where we left off. With Tip Top Corporation producing a product that requires 6 standard pounds per unit. The standard price is $4.50 per pound. If 3,000 units required 18,500 pounds, which were purchased at $4.35 per pound, we need to determine what's the direct materials price variance, quantity variance, and cost variance. So let's start with the direct materials price variance. And I am going to bring up a pen, and I apologize for my lack of penmanship when it comes to using a mouse as a pen, just so you know ahead of time. So for the direct materials price variance, we had an actual purchase at $4.35 per pound, right here. So $4.35. This is our for real. However, we were expecting a standard of $4.50 per pound, as we see right here. So $4.50. Now, what does that equal? We take 435 and we reduce it by 450. That is going to give us negative 15 cents per pound. Now we want to take that and we want to multiply that by the amount of pounds. So we multiply that by here, and that is going to give us a favorable or a negative 2775, as we can see there. Let's see if I can erase. I can. All the ink on the slide. There we go. So here it is in a much better representation. Now let's think about the direct materials quantity. So for quantity, now 3,000 units required 18,500 pounds. We recognize that right here. Now, that's what we were expecting, right? Well, that's what we experienced. My apologies. However, based off what we know, should be 6 pounds times 3,000. That's good old 18,000. So we actually had 500 pounds more than we were initially expecting. We multiply that by the $4.50, which is the standard price, and that gives us a $2,250 unfavorable variance. We used more materials than we expected. So when we take those two and we net them out, although we have a favorable variance of $525, we know that that favorable variance is solely attributable to the direct materials price, for us only paying $4.35 a pound when we were expecting to pay $4.50 a pound. We need to look at the efficiencies and go into operations and determine why We used 500 extra pounds on this particular period. So during June, my friends at Western Ryder reported an unfavorable total direct labor cost variance of 2,500 for the production of those 5,000 XL style jeans. This is based off the following actual and standard costs. We were expecting 38.5. We were expecting 36,000. We had actual of 38.5, resulting in the 2,500. When we look at the breakdown of the 38.5, so we have in actual rate per hour of $10 per hour, and we had hours of 3,850 of actual time. This gave us our 38,500. Then let's go and let's look at how the standards break. We were expecting $9 per hour in 4,000 hours for 36,000. So when we want to compute the variance, we start with our actual rate per hour, reduce that by our standard rate per hour, and multiply it by actual hours. If the actual rate per hour exceeds the standard rate per hour, we deem that as unfavorable. Where if the actual rate is less than the standard rate, that's favorable. We paid less than expected. So here's the basic calculation for the direct labor rate variance for Western Ryder Incorporated. We had $10 an hour. We were expecting 9. So we paid $1 an hour more than we were initially intending. We had 3,850 hours, so that accounts for $3,850 of unfavorable variance related to the direct labor rate. Now the time variance. This is our efficiencies. How well were our employees working? With that, we need to take our actual direct labor hours, reduce it by those standard direct labor hours, and multiply it by the standard rate per hour. So if the direct labor hours for the units produced exceeds the standard, that is unfavorable. And of course, the vice versa. Actual direct labor hours for the units produced is less than the standard direct labor hours. That's deemed favorable. For Western Ryder, they had actual direct labor hours of 3,850. However, the standard direct labor hours, what they expected, were 4,000. So they were able to save 150 hours multiplied by 9, giving them a favorable variance of 1,350. Like direct materials, the codependency of these two relationships resulted in a total 2,500 unfavorable variance. We offset some of the direct labor rate variance by saving some time. We paid more, but we didn't have as many hours. However, the two didn't wash out completely, resulting in an unfavorable variance. You report those direct labor variance to the various production supervisors who are responsible for controlling that. So these are the supervisors who are scheduling their employees and overseeing them. An unfavorable rate can be caused because we scheduled too many people. We used the wrong employees. It just took those particular people more time. Sometimes skilled, highly paid employees may have been used in jobs that would not normally be performed by them. In that particular case, the unfavorable rate variance should be reported to the managers who scheduled those specific work assignments. An unfavorable time variance can be because you don't have as many skilled employees as you would like. You may have newer employees, an abnormally high turnover rate on the line, employees that are in the beginning stages of their experience, so they take longer. When you have a production supervisor that has a high turnover rate, you need to look at it and wonder why are their employees quitting or transferring out. Here we'll look at Tip Top Corp, who produces a product that requires 2.5 standard hours per unit at a standard hourly rate of $12 per hour. Now, if 3,000 units require 7,420 hours at an hourly rate of $12.30, let's look at what the direct labor rate variance is, the time variance, and what the total direct labor cost variance is. So for the direct labor rate variance, we experienced $12.30 an hour. It required $12.30 an hour. We were expecting $12 an hour. So we have 30 cents multiplied by the actual or the required hours of $7,420 for an unfavorable variance of $2,226. Now let's look at the time. It took us 7,420 hours. Now, normally it should be 2.5 standard hours for 3,000 units, which is 7,500 hours. So if we take that and multiply that by the $12 standard cost per hour, that means that we had a $960 favorable variance. When we take the two and we net them out, we end up with a $1,266 unfavorable variance. We're getting ready to move into factory overhead variances. Let's go ahead and take about a minute and a half here to digest this and switch our gears because remember, factory overhead is not necessarily something that is controllable by the manager, but it's going to have some mixed elements related to it. The factory overhead variances apply to those costs that are associated with the factory overhead. So we have to look at them differently than direct labor and direct materials. Within your factory overhead costs, you have those fixed elements, and then you have the variable cost elements. Now, keep in mind that your fixed elements are not going to change in correlation with the change in production, whereas your variable cost elements will on a total. So, factory overhead costs are budgeted and controlled by separating them into their fixed and variable components. This allows the preparation of those flexible budgets we talked about in the last chapter and an analysis of the factory overhead controllable and volume variances. Some of the things you have to really keep in mind is that not all costs are controllable by all level of managers. So we're going to look at factory overhead cost budget, showing our standard factory overhead rates depending on capacity. You see, we have a percent of normal capacity line, which would be units produced, the hours we expect, the variable costs associated with it, and the fixed costs. We're going to use Western Writer as we continue through with this specific example. Utilizing the information we had, The budgeted factory overhead rate for Western Rider would be computed by taking our budgeted factory overhead at normal capacity and dividing it by our normal productive capacity. So we were expecting $30,000 for 5,000 direct labor hours. This means that for the driver of a direct labor hour, we're looking at $6 per direct labor hour. As we go in to analyze that, this needs to be subdivided into the variable rate and the fixed rate, because our fixed is not going to change in total, whereas our variable will. So for Western Rider, the variable overhead rate and the fixed overhead rate are calculated by taking the budgeted variable overhead at normal capacity, divide it by the normal productive capacity, and for this case, we get $3.60 per direct labor hour. For the fixed factory overhead, we take that budgeted fixed overhead at normal capacity and divide it by the normal productive capacity, and we get $2.40 per direct labor hour. So in summary, the budgeted factory overhead rate is actually a total of $6 an hour. It just breaks down into those two different components, variable and fixed. The variable factory overhead is called the controllable variance. This is the difference between the actual variable overhead costs and the budgeted variable overhead costs for production that actually occurred. If the actual variable overhead is less than the budgeted variable overhead, so if what we paid out is actually less than what we would have budgeted, the variance is variable. And the flip side, if the actual variable overhead exceeds the budgeted variable overhead, then that's unfavorable. So this standard variable overhead for actual units produced underneath the variable is computed by taking the standard hours for the actual units produced, and then we multiply it by the variable factory overhead rate. So here we have the information again for Western Rider. You notice that we don't change it. Still got 5,000 units of XL jeans. These are their various costs. And based on the actual variable factory overhead that we incurred in the month of June, the variable factory overhead controllable variance is a $4,000 favorable variance. We actually experienced 10,400. Based off the budget, the 4,000 direct labor hours that it should take to make the 5,000 units multiplied by 360 would be 14,400. So we actually have $4,000 favorable variance. This indicates the ability of the company to keep the factory overhead costs within their budget limits. Because variable factory overhead costs are typically considered controllable at each department's level, the responsibility for controlling this variance and the reporting would go to the department's supervisors. Here we have Tip Top Corp producing 3,000 units that required 2.5 standard hours per unit. The standard variable overhead cost per unit is $2.20. The actual variable factory overhead was 16,850. Let's determine the variable factory overhead controllable variance. So what is the actual variable factory overhead? They give us that. That's right here. That's 16,850. Then we need to determine what the budgeted factory overhead is. So for 3,000 units, because we know that's what was produced, and it should have been 2.5 standard hours per unit, we come up with 7,500 hours. Now, if we take 7,500 hours, we multiply that by $2.20 per hour, we get 16,500. So when we take the 16,850, reduce it by the 16,500, we get a $350 unfavorable variance. The fixed factory overhead volume variance is the difference between the budgeted fixed overhead at 100% normal capacity and the standard fixed overhead for those actual units that were produced. So for this, here is our basic equation. We'll move into looking at that here in the next slide. The volume variance measures the use of our fixed overhead resources. This is our plants, our equipment, everything that we have that comprises our total capacity. The interpretation of favorable and unfavorable is done by taking these following assumptions. So we have an unfavorable fixed factory overhead volume variance. That's a lot of repeating words with the same beginning letters. This happens when the amount of units that we actually produce is less than 100% of normal capacity. So the company used its fixed overhead resources, its plant, its equipment, less than would be expected underneath normal operating conditions. Favorable occurs when the actual units produced is over 100% of the normal capacity. So therefore they were more efficient. They were able to produce more than would be expected under normal operating conditions using the exact same overhead resources. So we compute it by taking standard hours for 100% of normal capacity. That is our 5,000 direct labor hours. And then we reduce that by the standard hours for the actual units that were produced. We reduce that by 4,000 because that is how many actual labor hour or standard labor hours would occur for our actual production point. Then we multiply that by the fixed factory overhead rate of $2.40. That gives us an unfavorable variance of 2,400. Now the next slide is a great graphical representation of the fixed overhead volume variance and how it functions. So you'll notice here we have our standard fixed overhead at $2.40. And that is this line. So as we produce more, it continues to rise. Continues to rise in dollars as we produce more. We know that 100% capacity is 5,000 units. So that's this point here. Anything that falls to the left is going to fall into the unfavorable, and anything that falls to the right would be favorable. So as managers, you're going to have to figure out why something is unfavorable or why something is favorable. You have to take a step back and you need to look at this because you may be the one who is responsible. What occurred? Unfavorable variances can come from a variety of factors. These are just a few. Maybe we couldn't maintain an even workflow. It was stop and start. Maybe our machines are breaking down. That's what caused the uneven workflow. Maybe work had to stop because we didn't have materials on hand or our people were ill. Maybe there weren't enough sales orders in place to keep the factory operating at its normal capacity. Again, some of these you will be able to control, some of them you won't. But what you do need to do is identify those components so that you can plan accordingly in the future. Or so if some part of it is within your realm of control, such as machine breakdowns. Why were the machines breaking down? Did you fail to order preventative maintenance? Or are the machines just really old and we need to order new machines? So we are going to stop on this slide. I want you to go ahead and calculate all of this. And then when we come back, I will have the answer at the beginning of the next lecture. We're almost 2/3 through here talking about standard costs.